All right, chapter 5, the first two sections, we are going to be doing lots of kind of like puzzle pieces, all right? There are no numbers involved here. You might have a 1 every now and again, but other than that, it's just all reasoning. Now, these are your fundamental trig identities. You will be given these on any test or quiz. You do not have to memorize them. You will be given them on a sheet of paper for you to reference, so don't worry about that. But as we work through these things, you're going to become more and more familiar with them, and I think it's going to be easier for you, I promise. Some things I want you to remember. Let's write down some things. When we simplify, what does the word simplify mean to do? Break it down, right? Make it smaller. When you simplify, when you are trying to prove these identities, sine and cosine, write this down. Sine and cosine are your most basic identities. All right? When all else fails, try to just change things into sine and cosine. Meaning, when you guys see something that says tangent, and we're simplifying or we're proving, you want to change it to in terms of sine and cosine. So anytime you see a tangent, you're going to rewrite it as sine of whatever angle over cosine of whatever angle. All right, these are reciprocal functions. You guys are familiar with these reciprocal functions. We're going to do one problem. We're going to do one problem right here in a second. That's reviewing what we did last time I saw you guys around Thanksgiving. And then we're going to get into some simplifying stuff. Now, these identities down here are called the Pythagorean identities. Can you hand me my water, please? Why do you think they're called the Pythagorean identities? Mm-hmm. Right? Don't they kind of look like Pythagorean Theorem because it's got squares in it? All right, what you guys need to notice, what you guys need to understand is the Pythagorean identities, whenever you have something that is attached to a plus or minus 1. Like if you have cotangent squared theta minus 1. You want to look at Pythagorean identities when you have a trig function squared and a plus or minus 1. Now, another thing I want to bring to your attention. If you have tangent to the third power of theta, right, we're simplifying. What did I tell you the most basic trig functions are? Sine and cosine. So look at your identities. Tangent is the same as what? Sine over cosine. So if you have tangent cubed, that's the same as sine cubed over cosine cubed. All right, if it was to the fourth, it would just be sine fourth over cosine to the fourth. Those things kind of stay the same. All right, you okay? Okay, we're going to go through some more, I promise. Now, we'll talk about these other identities later, but this is something that you guys learned before Thanksgiving. I did this with you. We're just going to review this to make sure that we remember. If you're given a trig value and you have to find all of the other trig functions, okay, let's think about this for a second. Secant goes with what trig function? Cosine, right? So cosine is what letter over what letter? Anybody remember? Y over r, x over r. Cosine is x over r. So secant would be r over x. Agreed? Okay, so this would be my r value, and this would be my x value. Okay, so in order to find all 6 trig functions, you need x, you need y, and you need r. Agreed? So my r is 3, and my x is 2. How do I know where that negative sign goes? Okay, let's remember this. R can never be what? Can never be negative. If R can never be negative, so then where does the negative sign have to go? With the x, okay? So I have to find my y value, but they told me another piece of information right here that is super duper important. Okay, remember all students take calculus. All right, so if I know, if I know that my secant and my cosine value are negative, right? I know that from this given information here. I know that my angle is not in the first quadrant and it's not in the fourth quadrant, right? Now, the second piece of information is really important. That says the tangent is greater than 0. That means it's what? Positive. Where is tangent positive, guys? in the third quadrant. Why was that really important information for me to know? What do we know about the x value and the y value in the third quadrant? They're both negative. So you need to know that your y value is also negative, right? If we skip, if we miss a sign on something like that, it messes everything up. So those two pieces of information just told us so much according to the signs of our y and our x value. Now, in order to find the y, then we use our Pythagorean theorem. So I have negative 2 squared plus y squared equals 3 squared, right? So 4 plus y squared equals 9. Y squared equals 5. Agreed? Take the square root. And so my y is negative square root of 5. If you didn't use that second piece of information, that tangent was greater than 0, you might have missed that and put positive 5. And then now that we have this stuff, guys, it's super easy to figure out all of your trig functions, right? Sine of theta is y over r. Cosine theta is x over r. Tangent of theta is what? Y over x. So cosecant theta is going to be r over y. Secant of theta is going to be r over x. And our cotangent theta is going to be x over y. Now, what do we already know? Two things we already know. My secant is negative 3 over 2, right? And my cosine is negative 2 over 3. Agreed? Okay, so sine is going to be y over r. So it's going to be negative root 5 over 3. Agreed? So then my cosecant is going to be negative 3 over root 5. Can I leave it like that? WebAssign lets you, but Mrs. Meadows doesn't. So we have to rationalize. So it's negative 3 root 5 over 5. Our tangent is going to be y over x. So negative root 5 over what? Negative 2, which just becomes root 5 over 2. Cotangent is going to be negative 2 over negative root 5. Two negatives give you a positive, and then we have to rationalize our denominator. So it's going to be 2 root 5 over 5. All right, for these problems, everything you do in section 5.1 and 5.2, you should take a screenshot of those fundamental identities and put it right next to the problem. So I'm going to do that. I'm going to pull in an existing image. Excuse me. And we're going to stick it right here so we can refer to it. It's very important that you have this so you can refer to it. You will have this on your test and quiz, I promise. Now, I cannot impress upon you enough, guys. This is very different from anything that we've done. So don't get frustrated. Just kind of work with me here. We're going to look at it. Just have some patience. The first example tells you to simplify. Remind me again what simplify means. To break down, to make smaller. Now, a lot of times when we do this, I'm going to tell you guys to think algebraically. When I say think algebraically, you don't have to do this. I'm just visually showing you this. This problem is the same as saying like a times b squared minus a. Algebraically, it says the same thing. What would you do if you were going to simplify this? What's the first thing you would take out? What do they both have? They both have an a. You would take out the a, and you'd be left with b squared minus 1, right? Agreed? Okay, so we're going to think algebraically. We're going to think that same way. When you simplify, your answer should be smaller than what you start off with. Sometimes you're going to be like, I don't know if I'm done or not. You just keep going back to your identities and say, can I break it down? Can I break it down? So here is my problem. What can I factor out of sine x times cosine squared x minus sine x? They both have a sine x. So I'm going to take that sine x out. And when I divide by sine of x, I'm left with cosine squared x minus 1. Does everybody agree? Yes? Okay. So let's look at our identities. Okay, sine's pretty simplified. Cosine squared x minus 1. I told you, if you have a trig function squared with a plus or minus 1 attached to it, where should we look? The Pythagorean identities. Good. Is there an identity that you see over here that has a cosine squared and a 1 in it? The first one, right? Okay, so I'm going to write it out. Sine squared x plus cosine squared x equals 1. Now, I want to rearrange this so it says cosine squared x minus 1 equals something. Can I do that? Algebraically, can I move stuff around? Yeah, absolutely. Do you guys agree with me that I could subtract 1 from both sides, right? So I have sine squared x plus cosine squared x minus 1 equals 0. Agreed? Okay, I wanted to just say cosine squared x minus 1 equals something. So what would I do with the sine squared x? Not divide. How would I move that positive sine squared x to the other side? I can subtract it. Yep. Minus sine squared x minus sine squared x. So I have cosine squared x minus 1 equals negative sine squared x. Agreed? So right here, this cosine squared x minus 1, I can replace it with what? Negative sine squared x. So I have sine of x on the outside times negative sine squared x. Can I simplify that? Can I combine those? Yeah. What's sine squared times sine? Sine cubed. So this becomes negative sine cubed of x. And that's as simplified as you can get it. What you did was you took this initial expression here and you simplified it to that. Those two things are equivalent. They mean the exact same thing. You just simplified it. When you simplify, you're going to start off with something messy and it should turn into something a little cleaner. Now you're looking at this and some of you would say, well, how do I know that I'm done? Well, if I look back at my identities, the only thing I can do now is I could change sine into 1 over cosecant. But what are our most basic trig functions? Sine and cosine. You want to try and, you don't want any fractions in your answer if you can avoid it. And you want to try to get to sine and cosine. So that's it. All right? All right, let's look at the next example. Example 3. Example 3, the directions are a little different. What does it tell you to do? Factor. Do you guys know how to factor? Yeah, for sure you do. I told you when we're doing these problems, sometimes I'm going to tell you to try and think algebraically. A says secant squared theta minus 1. That's the same thing as saying x squared minus 1. Do you guys know how to factor that? What would you say? X minus 1, x plus 1? Agreed? All right, so it's the same thing. How do you get secant squared? Well, you'd have to multiply what? Secant times secant, right? So it'd be secant theta. What times what? What I multiply to get my negative 1? It's the difference of perfect squares, isn't it? So what would go in my parenthesis? Plus 1 and minus 1. That's it. B is a trinomial. It says 4 tangent squared theta plus tangent theta minus 3. Well, if I rewrote that algebraically, just using x's instead of my trig function, what would it look like? 4x squared, right? Plus x minus 3. Do you guys know how to factor that? Of course you do. A times c. What's 4 times negative 3? Negative 12. What are my factors of negative 12? That multiply to give me negative 12, but add to give me 1. Plus 4, good, minus 3. Since my a term is not 1, what do I do with that 4? put underneath. So this becomes x plus 1, and this becomes 4x minus 3. Agreed? Mm-hmm. Now, you guys don't have to change this to an algebraic problem. I'm just showing you how it's the same thing. What would I replace my x with? Tangent. So this would be tangent theta plus 1 times 4 tangent theta minus 3. If that confuses you to change it to an algebra problem, don't. Just notice that it's a quadratic. You guys have seen this a million times. What do you notice about the trig functions? They're the same or are they different? They're both what? Tangent, right? Okay. So when they're not both the same, you just have to get them to be the same. No big deal. This is all the same concepts that you guys have learned over and over and over again. You're just now using trig identities with it. You guys can do it. Okay, again, as soon as you get a problem like this, you say, okay, I got to get my identities. Let's go. So what do the directions say on example 4? What do they want you to do? They want you to factor. Okay, again, you're going to factor. Now, I'm just showing you this algebraically again. What do you notice about the two trig functions that are in here? They're different. Do you guys see? This is like saying x squared minus y minus 3. Can you factor like that? No. But you can use your identities, guys, to get the trig functions to be the same. When you have a quadratic and they're not the same trig function, always, 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 always try to convert to the middle trig function. So I'm going to try and change cosecant squared to cotangent. Is there anything on my identities that could help me change cosecant squared to cotangent?
1 plus cotangent.
1 plus cotangent is the same as what? Cosecant, right? Everybody see that right here? 1 plus cotangent. So I'm going to change this to 1 plus cotangent squared x. Then I still have minus cotangent x minus 3. Think algebraically. Do you see anything that you can combine?
1 and negative 3.
Yeah, 1 and negative 3. So this is the same as cotangent squared of x minus cotangent x minus 2. Do you have a quadratic? Yes or no? That you can factor? Yeah. Quadratic means the highest exponent is 2. Do you have a quadratic? Yeah, so we can factor this now. What times what gives me cotangent squared? Cotangent and cotangent. So that goes in the front of each parenthesis. What times what will multiply to give me a negative 2, but add to give me a negative 1? Plus 1 and minus 2. And there you guys have factored the expression. Whenever they tell you to factor, and it's a quadratic, it's like any trinomial that you guys have done before. If the functions are different, you want to convert to the middle function. Always convert to the middle one. All right, we're going to do one more example, and then I'll finish up tomorrow. We'll finish up tomorrow. Simplify. What does that mean? Am I factoring it? No, simplify means to make it smaller, right? We're going to make it smaller. So, if again, you guys are like, I don't even know where to start. That's okay. Remind me again what I told you at the beginning. What are the two most basic trig functions? Sine and cosine. So let's just try and break this down. All right, can I make sine into anything else that's more basic? No. So just rewrite it. I'm going to use theta because my t's are going to start to look like plus signs. So I'm just going to keep sine the same. What can I change cotangent into? Cotangent can turn into what? 1 over. Okay. But what's the most basic that we're trying to get to? Cosine over sine. So I'm going to change cotangent to cosine theta over sine theta, right? And that's being multiplied by what? Cosine theta. All right, remember, our two most basic trig functions are sine and cosine. If we're simplifying, you want to go to the basics. Do you guys agree with me that this is sine of theta over 1, right? Yes? Okay. Plus, what's cosine times cosine? Cosine squared theta over sine theta. Agreed? Now, if these were being multiplied together, what could I do with the signs? I could cancel them out. But they're not being multiplied together, are they?
No.
They're being added. Do you guys agree with me that all this is, it's just two fractions that are being added together? Yeah? When you add fractions, you have to have a common what? Gotta have a common denominator. So between sine of theta and 1, what's your common denominator? Sine theta. So if I multiply the bottom here by the sine of theta, what you do to the bottom, you do where? To the top, right? So what's sine times sine? Sine squared. Good, Raul. Sine squared theta plus cosine squared theta over the sine of theta. Now, we're in all sines and cosines, right? So some of you might be like, well, oh, do I just stop here? Well, let's think about it for a second. Look at your identities. Is there anything that I could simplify sine squared theta, cosine squared theta?
Sine squared theta plus cosine squared theta equals 1.
It does equal 1. Sine squared theta plus cosine squared theta just equals the number 1. So you have 1 over the sine of theta. Now, I would go one step further, because when you fully simplify it, I told you guys want to try and get away from fractions. What is the same thing as 1 over sine of theta? Tell me. Julian, tell me. Cosecant theta. Perfect. So you started off with this, sine of theta plus cotangent theta, cosine theta, and you simplified it to the cosecant of theta. We're just breaking down. We're just manipulating things. You guys are going to think very basic, very algebraically. Combining fractions, you got to get a common denominator, those sorts of things. And you're just going to keep referring back to your identities. The more you practice this, the easier it gets. I promise. Promise, promise, promise. I'll finish. Hang on one sec. I'll upload part 1, and then tomorrow I'll finish. I'll just do the last example. And you guys will have time to work on your web assignment tomorrow in class. I do suggest that you start it, though, tonight. At least pull it up, look at it. If you have any questions, you can ask me tomorrow when we go over things. But just you have to practice. You can't just give up and say, oh, I don't know how to do this. It's too hard. You have to keep trying.